Methodology of teaching natural science. Welcome to a new session on the various approaches of teaching science. Here we will be dealing with the differences between the inductive and deductive approaches. We will also have a discussion on the inquiry and discovery approaches of teaching science. Inductive, deductive, inquiry and discovery approaches of teaching. Inductive-deductive approach. The major problem of the science teacher is to provide pupils with appropriate learning experiences for achieving the goal set before the pupils. The major criteria of selecting learning experiences are the needs and interests of the pupils. The learning activities the teacher selects should help the pupils to develop their power of thinking, discover, develop capacity for reasoning rather than rote memorization, and provide training in scientific thinking. Attempting to learn science inductively as well as deductively will help the student to achieve these objectives in a most efficient and economical manner. The two approaches are mutually supplementary and aim at establishing the validity of the thought process. Deduction can give us only formal validity because the premises are taken for granted. This formal validity may be misleading if the general statement is wrong. Induction tests the material validity, but there is always a need for induction to supplement deduction. As far as our classroom situations are concerned, inductive approaches are always preferred because we proceed from concrete to abstract, from known to unknown, from the observed to unobserved, and from the empirical to the rational. All the maxims of good teaching are taken into consideration in the inductive approach. Good teaching always starts with induction and ends in deduction, where the knowledge gained is applied, verified, and established. Inductive approach is most suitable in lessons in the following categories: where rules are to be formulated, where definitions are to be framed, where generalizations are to be made, where general laws are to be arrived at, and where causal connections between facts are to be established. But in higher classes, inductive method is sometimes not so useful as in lower classes. It is lengthy and becomes tedious and boring for them. With the beginners, it is difficult to follow the deductive method as it proceeds from general to particular and from abstract to concrete. The practical way is that they should go side by side, supplementing each other. That is, induction should always be followed by deduction, and deduction should be established through induction. Inductive approach. In the inductive approach, the student accumulates a large number of observations and then summarizes his findings with a general statement. The mind of the learner moves from particular to general through observations of particular facts and examples. One of the important parts of searching new knowledge in science is to formulate and test hypotheses. Hypotheses are simply tentative explanations put forth to account for observed phenomena. Formulating testable hypotheses draws heavily on the scientist's creativity and imagination. One of the general patterns to formulate hypotheses is inductive logic or induction. If a person tastes a green apple, he or she finds it sour. If they repeat such experiences, they relate the characteristics of green apple to the other characteristic of the apple, namely sour. Thus, they draw a generalization. All green apples are sour. This is known as inductive method. It has four characteristics. It begins with observations. It leads to development of hypothesis. It proceeds from specific to general. It is a method of discovery. Inductive method was founded by Francis Bacon. Induction is the process of arriving at some kind of order, law or regularity from the facts observed. Here, mind moves from particular to general, easy to difficult, simple to complex, familiar to unfamiliar, known to unknown, concrete to abstract, nearer to distant, actual to representative, empirical to rational. For example, the water at the beach has always been about 75 degrees in July. It is July, therefore, the water will be about 75 degrees. In induction, we arrive at the general or more general from the particular or less general. It proceeds from known to unknown. All inductive inferences are based on the following two assumptions. The law of uniformity in nature, that is, nature is uniform in its behavior. A phenomena that has taken place in certain circumstances will repeat itself whenever that circumstance occurs. Example, dark cloud is the cause and rain is the result. The law of causation, that is, nothing takes place without any reason or by chance. Every phenomena has a cause or a set of causes. It is not possible to give a theoretical proof of this assumption, but the results of inductive investigations based on the assumptions are evidence to their truth. Brunner supported inductive learning, in which teaching began with the specific experiences of the learner and then built upon them to the general idea of the subject. Students are not passive learners. They learn best if their minds act on what is being learned, and this mental action occurs through listening, speaking, reading, seeing and thinking. Brunner encouraged induction as one way to promote learning and as a way to form and understand concepts. Induction consists of some steps beginning with the child exploring the topic in his own way and gathering ideas. In Brunner's system, the meaning is further strengthened by the examples given by the teacher, helping in generalization formations and principle development. The generalization comes by making thoughtful comparisons or by finding regularities or irregularities. Brunner recommends for specific activities to help them to understand concepts and relationships. Step 1. Students obtain experiences and provide specific examples of concept to be discovered. Step 2. Teacher helps students examine their examples and identify common and uncommon characteristics. Step 3. Teacher guides students' thinking and helps them form concepts or general ideas. Step 4. Students expand their understanding of concept by using it under different circumstances. Deduction. In deductive approach, the mind tries to explain particular facts by applying the various implications contained in a general statement or verify a general rule through its application to particular facts. Thus, deduction is the reverse of induction. How do experiments test hypotheses? Experiments test hypotheses by testing the correctness of predictions that can be derived from them. This process involves the deductive logic or deduction. Some of the characteristics of deductive logic are: deductive approach begins with hypothesis which leads to predictions. It proceeds from general to specific. It is a method of verification. Deduction was founded by Aristotle. It is the reverse of induction. Here facts are deduced or analyzed by the application of established formulae as experimentation. Here the approach is confirmatory and not explanatory. In this method, the students proceed from general to particular, from abstract to concrete, or from established principles to their application. For example, all noble gases are stable, which is the major statement. Helium is a noble gas, which is the minor statement. Therefore, helium is stable, which is the conclusion. From the general statement that all noble gases are stable, it might be legitimately inferred that helium, being a noble gas, is stable. The truth of deductive inference depends only on the accuracy of the generalization in which it is based. So, the method is useful in testing hypotheses, laws and theories, and also in applying generalizations to explain new phenomena. Ausubel believes that structured concepts can be taught to students. He regards the human mind as a system for receiving, processing and storing information. Ausubel advocates learning new ideas, relating them to available concepts or anchoring ideas. Ausubel's advanced organizers help learners link new ideas with existing concepts. Advanced organizers fit well in a direct instruction method called deductive teaching, the opposite of Bruner's inductive teaching. An organizer helps to provide a foundation before the teacher presents the abstraction or generality of a lesson, then proceed to clarify terms, provide example, and students work with specific examples. Step 1. Teacher presents abstraction or generality of lesson. Step 2. Teacher clarifies key terms. Step 3. Teacher provides examples. Step 4. Students work with specific examples. Distinction between inductive method and deductive method. In inductive method, we have to proceed from particular to general, whereas in deductive method, we have to proceed from general to particular. In inductive method, one draws out conclusion or principle, whereas in deductive method, the rule or principle is told beforehand. In inductive method, children themselves discover the rule or principle, whereas in deduction, children have to depend on others for discovering the rule or principle. Inductive method is very useful and interesting for small children. Deductive method is useful for young students of higher classes. In inductive method, all the work is done by the child, whereas in deductive method, all the work is done by the teacher. Induction is a method of teaching. The child enhances his mental development. Deduction is also a method of teaching. In this method, one gets direction. Much time is taken in teaching in inductive method, whereas less time is taken in teaching in deductive method. In induction, the child is free to think independently and can put up any logic. In deduction, the child is not free to think independently, nor can he put up any logic. In induction, the child attains new knowledge. In deduction, knowledge is applied to a new situation. Inductive method is a way of invention, whereas deductive method is a way of imitation. The method of induction teaches us to believe in observation, decision and experience. The method of deduction gives a chance to apply the experiences to particular observations. Enquiry and discovery approaches of teaching. In most of our classrooms, science is being taught as a body of facts and the teacher passing on the factual information and pupils learn them by heart. On the other hand, a modern science teacher should be a stage setter and initiator of scientific thinking. The functional concept of science and the use of proper methods of teaching will make science teaching and learning effective and useful. Discovery approach. Discovery learning takes place in problem-solving situations where the learner draws on his own experience and prior knowledge, and is a method of instruction through which the students interact with their environment by exploring and manipulating objects, wrestling with questions and controversies, or performing experiments. In the discovery approach, the student is often sent into the laboratory as a researcher or investigator to investigate a scientific problem in hand. The student collects data by observation and experiment, which he uses for understanding the scientific principle. They become self-learners. They organize and systematize their findings, which provide an opportunity for analytic thinking. They also learn that science is more than facts given in books or mentioned by authorities. Discovery learning is a technique of inquiry-based instruction and is considered a constructivist-based approach to education. It is supported by the work of learning theorists and psychologists Jean Piaget, Jerome Bruner, and Seymour Papert. Bruner argues that practice in discovering for oneself teaches one to acquire information in a way that makes that information more readily viable in problem solving. The label of discovery learning can cover a variety of instructional techniques. A discovery learning task can range from implicit pattern detection to the elicitation of explanations and working through manuals to conducting simulations. Discovery learning can occur whenever the student is not provided with an exact answer, but rather the materials in order to find the answer themselves. Criticism of pure discovery learning. Students are more likely to remember concepts if they discover them on their own as opposed to those that are taught directly. This is the basis of discovery learning. In pure discovery learning, the learner is required to discover new content through conducting investigations or carrying out procedures while receiving little, if any, assistance. Because students are left to self-discovery of topics, researchers worry that learning taking place may have errors, misconceptions, or be confusing or frustrating to the learner. Mayer argues that unassisted discovery learning tasks do not help learners discover problem-solving rules, conservation strategies, or programming concepts. He does acknowledge, however, that while under some circumstances constructivist-based approaches may be beneficial, pure discovery learning lacks structure in nature and hence will not be beneficial for the learner. Several groups of educators have found evidence that pure discovery learning is less effective as an instructional strategy for novices than more direct forms of instruction. While discovery for oneself may be an engaging form of learning, it may also be frustrating. The main idea behind these critiques is that learners need guidance, but later, as they gain confidence and become competent, then they may learn through discovery. Enquiry approach. Enquiry is a process by which children actively investigate their world through questioning and seeking answers to their questions. This process is characterized by actions such as probing, searching, exploring, and investigating. Leaders in science education have actively promoted enquiry science since the 1960s and continue to do so today. The US National Science Education Standards recommend that science instruction and learning should be well grounded in enquiry. In spite of these efforts, however, little has changed in the way science is taught. Teacher talk and textbooks are still the primary providers of science information for students. Enquiry as a way of learning about the world should be taught in the context of real-life scientific problems involving real science knowledge. These problems should be relevant to the students. The students should initiate study of these problems as they probe, search, explore and investigate problems and questions of interest to them. Teaching science by enquiry. Teaching science by enquiry involves teaching students the science processes and skills used by scientists to learn about the world and helping the students apply these skills involved with learning science concepts. Students are helped to learn and apply these processes through conducting problem-centered investigations designed for learning specific science concepts. The teachers help students generate questions to guide these investigations. This enquiry approach is often referred to as guided discovery. Teachers guide students' enquiry until the students discover specific science concepts predetermined by the teachers. By learning science by inquiry, students develop deeper understandings of science concepts and also develop critical thinking skills. However, it is important to stress that learning science concepts by inquiry is much more time consuming than learning concepts by traditional methods. Guided enquiry. The teacher provides the problem for investigation as well as the necessary materials. Students are expected to devise their own procedure to solve the problem. Example, cell factory. This activity is a fun way for the students to demonstrate their understanding of the basic structures of cells and the essential functions in cells. Students build a model of a factory where each factory part is compared to a cell part via the function. Unguided enquiry. Through unguided enquiry, students address a problem or issue through first-hand experience with plentiful materials and information services. The teacher serves as a facilitator instead of a presenter. Many possible answers or solutions may be presented. 3 reasons why enquiry science has not been widely implemented. Science teaching standards issued by state education agencies are generally more content oriented than process oriented. It is much easier to evaluate the effectiveness of student learning of science as a body of factual information than to evaluate the effectiveness of their science learning through enquiry. Science textbooks tend to present science more as a body of information than as a method of inquiry, and science instruction continues to be textbook driven. Why teachers do not use enquiry based science instruction? Lack of training, lack of time, lack of materials, lack of support, overemphasis on assessing content learning rather than process learning. Enquiry approach is too difficult and much more time consuming. Advantages of discovery and enquiry method. Brunner has mentioned 4 advantages of this approach, which are: it increases intellectual potency of the learner. The learner learns and develops his mind by using it. It is based on intrinsic motivation rather than extrinsic motivation. The learner is searching for an answer to a problem, trying to discover something. As a consequence of succeeding at discovery, the learner gets a satisfying thrill which serves as intrinsic motivation. By practicing this method, students develop the ability to sense the relevance of variables, make intuitive leaps, and cast problems into forms which they know how to work on. Thus, they learn to organize and conduct investigation. The instruction becomes student-centered rather than teacher-centered. It increases the achievement level of the learner. It minimizes verbal learning and gives more time to students to assimilate and accumulate information. Limitations of discovery and inquiry approach. Some of the limitations in the Indian situation are: science teachers are not properly trained to guide students' learning through inquiry. Many teachers fear that during the use of inquiry learning, students will ask diverse questions which will be difficult to answer. One of the significant reasons is the limitation of the science syllabus, which does not promote inquiry learning. The science textbooks do not provide sufficient scope for discovery learning. Examinations are knowledge-based and questions are mostly recall type. Information is stressed and inquiry skills are de-emphasized. Students need apparatus and materials to explore and test their ideas. The non-availability of the material makes it difficult to work for most students. Discovery learning takes more time than receptive learning, therefore it is avoided. Now let us summarize. In this session, we had a discussion on the various approaches of science teaching, namely induction, deduction, discovery and inquiry. The advantages and disadvantages of these methods were also discussed. Here are some questions for you to work on. Differentiate between inductive and deductive approaches. Find out more examples for inductive and deductive reasoning. With a suitable example, describe the guided discovery approach in teaching science. List some of the advantages of the inquiry approach. Explain the law of causation. What are the advantages of discovery and inquiry methods? What are the challenges for implementing discovery learning in the classroom? Here are some books for your further reference. Teaching Science Through Discovery, 4th edition by A. A. Karen and R. B. Sun, 1980, published by Charles C. Merrill Publishing Company, Columbus, Ohio. The Inquiry and Discovery Methods of Teaching Science by R. D. Ollerinoy, 1982, from the Journal of the Science Teachers Association of Nigeria. On the Problem of Scientific Discovery by G. L. Farr, 1966, from the journal The Science Teacher. The Logic of Scientific Discovery by K. R. Popper, 1968, published by Harper and Row Publishers, New York. Inquiry-based science. Strategies and techniques for encouraging inquiry in the classroom by E. L. Schiapetta, 1997, from Science Teacher. Thank you for watching this program. See you next time with a new topic. Until then, bye.